final major class of lipids that we're going to look at is called steroids. And so steroids have as the base of their structure, the cyclopentaperhydrophenanthrene structure, where it's a fused ring system with 3 6-membered rings and then a fourth 5-member ring. So A, B, and C, which is a typical nomenclature for these rings, are all 6-membered rings, and then the fourth D ring is a 5-membered ring. And so a well-known steroid is cholesterol. So we'll draw that real quick. So there's our ring, there's the OH group. Okay, and then there's going to be stereochemistry in this. Double bond. Another one here. H. Make sure I got this right. CH3. Okay. Okay. I'm going to draw. Let's back this up. Make this a little larger so that we have room. And then we get rid of this. Okay, so let's see. Okay. Okay. This is cholesterol. Okay. And so these are precursors for a number of steroid hormones, including a few shown here, such as cortisol, testosterone, and aldosterone, and beta-estradiol. So these are the basic ring structures for a number of hormones which are involved in signaling, including for so the glucocorticoids are involved in metabolism and inflammation. Aldosterone regulates the excretion of salt and water from the kidneys, and androgens and estrogens are involved in sexual development. And so these are, for instance, testosterone and beta-estradiol shown here. Another one, which is a steroid based, is vitamin D biosynthesis. So commonly we think of vitamin D1 as a fortifier in milk, and 2, we also think of vitamin D as something that's made, for instance, when you go outside in the light. And so the reason for this is if you have this compound where at the R group, that's not right, yes, the R group is Y, such as shown here, which is ergosterol, or if it's X, 7-dehydrocholesterol at this R group, UV radiation, again from the sun, so again, the idea that this comes from being out in the light comes from this idea. It causes a cleavage of the 9-10, of the bond between the 9 and 10 carbons to form this compound, which then spontaneously goes to form this precursor here. Now the active form, which is important for instance for calcium uptake, since vitamin D is important for calcium uptake, and that's why milk is commonly enriched with vitamin D, is actually this molecule here, and this requires hydroxylation at 2 positions, at the 1 and the 25 carbon. And this is done by liver enzymes in order to form this final molecule. And this is what's important. So this needs, in other words, this needs some sort of modification within the body before you get the active compound, which is important for its physiological function. And again, one important physiological function that we think of when you think of vitamin D is calcium uptake in the intestines.